what are we doing? On Tuesday, what did we cover? We covered law 3, and law 3 was the law about raising a power to a power. So when we raise a power to a power, what do? I multiply my exponents. In case anybody forgot that rule, that is the rule. When I raise a power to a power, I multiply my exponents. And so let's look at this. I have 3x to the power of 8. That is my power, and I'm raising it to the power of 3. What I'm going to do is, I know 3 has an exponent of 1, and that is multiplied by x to the exponent of 8. Okay, and so how do I apply law 3 over there? I am going to apply law 3 into my brackets. And so that's going to look like this. I'm going to say 3, 1 times 3 times x 8 times 3. Uh-oh. Here we go, x 8 times 3. And let me close that up. What is that going to give me? That's going to give me 3. 1 times 3 is 3 times x. Can somebody tell me what is 8 times 3? It is 24. Thank you, everybody. 24. And is this my final answer? Is my final answer going to be 3 cubed x to the power of 24? Can somebody tell me yes or no? Is that my final answer? No. Tando, why no? What can I still do?
Ma'am, you still need to find out what's 3 to the power of 3.
I still need to find out what's 3 to the power of 3. You are 100% correct. And do you know what is 3 to the power of 3?
Ma'am, it's 27.
It is 27. Good job. Now are we done?
Um,
I see a ma'am, you are freezing. Is that for everybody? Guys, please give me a thumbs up if you can see me, hear me, if everything is working fine on your side. Okay, Liaho, I see your thumbs up. Thank you. Anybody else? Inifle, Mateo, Bri, Marangi, Kuyanda. Okay, that's great. Nkuli, try and check your sorry. Try and check your connection. Check your connection, because sometimes things will be a bit choppy if it's struggling to connect. So try and check your connection. If not, then don't worry. If you're missing whatever it is I'm saying, and let me type this in the chat in case she can't hear me. If you miss whatever I'm saying, you can watch the recording and it'll work perfectly. So that's for any of you who, like I said, if at any point you can't hear me, you get kicked out, you were just working out your sum and then you didn't hear what I said, that's okay. You can always ask me to repeat. But also, in my recordings, you can always go back and watch. If you are experiencing choppiness on your side, the recording will not have that. So guys, always go back to the recording when you miss something. Cool. Let's look at number 2. Anybody wanna volunteer for number 2? A brave soul. Ma'am, can you please re-explain how you got 27 and x to the power of 24, 100%? So let's go back and let's look at it. As I said, when we are dealing with law 3, what did law 3 say? Law 3 said, when I raise a power to a power, I multiply my exponents. And so when I look at the sum over here, which is 3x to the power of 8 raised to the power of 3. And so it's not a sum, it's an expression. When we look at this expression, how can I simplify this? Well, I know 3x to the power of 8 is actually 3 times x to the power of 8. Nialeti, I hope that you're with me there so far. If you're not, you can give me a thumbs down. But I just separated 3x to the power of 8 into 3 times x to the power of 8. And then what do I know about 3? 3 has this invisible exponent of 1. Then what did I do? I applied law 3. And what does law 3 say? Law 3 says when I'm raising a power to a power, and if you weren't here for Tuesday's lesson, when you raise a power to a power, it looks something like that. So it's when we have a power that has an extra exponent. So when we have a power that's being raised to another power. And so what we do is I take that exponent that's outside my brackets and I bring it into my brackets. And when I bring it into my brackets, I multiply it with the exponents in the brackets. And so here you can see I brought my 3 into my bracket and multiplied it with the exponent of 1. I also multiplied it with the exponent of 8. What did that leave me with? It left me with 3 to the power of 3. Refuel, yes, are you asking me a question? Okay, I think that was a mistake. Okay, then we have 3 to the power of 3 times x to the power of 24. How did I get that? 1 times 3 is 3. 8 times 3 is 24. And then all I did here in this step was I removed my multiplication. So I removed my multiplication in the middle and I got 3 to the power of 3 and x to the power of 24. Because I know if I write two things next to each other, I know that means we're multiplying. And so I removed my multiplication now, and then I simplified 3 to the power of 3. How did I simplify 3 to the power of 3? That is 3 times 3 times 3, which means 3 times 3 is 9, and 9 times 3 is 27. And that is how I got 27x to the power of 24. Nyeleti, I hope that makes sense. I hope that you're with me now. If you're still not, let me know. If anybody's not with me, you can let me know, and I will go through that again. But also, guys, watch the recordings. Okay, number 2. What are we doing for number 2? Okay, let's use my normal color. We have 2x squared over y to the power of 5. And yes, ma'am, thank you. Good, Nialeti. And let's look at how we do this. Here, I'm going to apply law 3 to my numerator, and I'm going to apply law 3 to my denominator. So if I just had a numerator, what would that look like? I would have gone and I would have said 2 1 times 9, and I would have said x 2 times 9. Okay, and then for my denominator, it's y 5 times 9. Let's simplify that. 2 and 1 times 9 is 2 to the power of 9, x to the power of 18 over y to the power. Somebody tell me what is 5 times 9, please. 45. Thank you, Kando. I just ruined all of my numbering, but that's okay. 5 times 9 is 45. Thank you to those of us who are answering in the chat. And then, am I done? No, I'm not done. Why am I not done? I have a number here, a whole number with an exponent. I can simplify that. So, those of you who have your calculators in front of you, can you tell me what is 2 to the power of 9? 512. Tando is so quick today. 512 over 18. Thank you, Liafo. Y over 45. And that is that. Everybody with me? Is anybody lost? You guys can give me a thumbs up if you are with me, thumbs down if you're like, ma'am, I have no idea what you just did. Okay, I see Liaho reacting with a thumbs up. Thank you. Tando, Lufuno, Morangi, thank you. Imihle, oh no. Where did you get lost? Where were you left behind? Can you do one more example? Okay, I don't have another revision example with the fraction, but guys, remember we are doing revision of Tuesday's lesson. So if you're lost, maybe you should go ahead and go rewatch Tuesday's lesson. Tuesday's lesson, and you'll see we have quite a few examples in Tuesday's lesson. Okay, Mihle, I see you giving me a thumbs up. Okay, that's that. Let's move on to our last revision question. Let's look at this. I have a power being raised to a power, but my 3 is not inside my brackets. So I am not going to apply law 3 to that because my -3 is not part of my power inside my brackets. And so let's see, where am I applying law 3? I'm going to apply law 3 to that exponent, and to that exponent. And what is that going to look like? I'm going to carry my -3 down. It's going to be x to the power of 3 times 3, y to the power of 5 times 3, z to the power of 8 times 3. What does that look like? -3, x to the power of 9, y to the power of 15. And again, 8 times 3 is what, everybody? Am I writing skewed? Yes, I am. 8 times 3. It's clearer now. I'm glad, Bree. 24. Thank you guys for answering me in the chat. And then I can now use, I know I don't have to write this brackets. I could have left it like this, but I know that this means multiplication. And I know if I go -3, x, 9, y, 15, 2, no, that's not 2, that's z. Z 24, that is the same thing. So these are the same thing. It's the same thing. I've just removed my brackets because I know my brackets means multiplication, and I know I don't have to write multiplication. I can just write my numbers next to each other. And so x9, y15, z24, your answer is correct. We can remove the brackets and have what I have here at the bottom. Okay, guys, I hope that all of these made sense. If it doesn't, go back and watch Tuesday's recording. Let us start with some new work. The last law you're going to learn for exponents. What does it say? It's our power of 0 rule. And before we even talk about that, I want to ask you guys a question. I want to ask you, if I have something like 7/7, can we simplify that? What is the answer to that? Imisha, you're only starting this tomorrow. That's great. You're going to be ahead of your class and it's going to make so much sense. Okay, I see you all saying 1. Yes, it is 1. I can simplify that into 1. Let me try that again using my exponent laws. If I had to use my exponent laws, how would we use my exponent laws? Think of law 2. It is a whole, Imithle. You are 100% correct. Try doing it now using my exponent laws. Think about the law 2, which was division. When I have division, what do I do with my exponents? Okay, I'm seeing some answers in the chat. What do I do with my exponents? I minus my exponents. Thank you, Tando. You beat me to it. I minus my exponents. So what does that mean? I kept my base The rule was that when I have the same bases and division, I keep my base and minus my exponents. And then 1 minus 1 is 0. So what is my exponent over here? My exponent is 0. But I know that my actual answer to this is 1. And so I want you to think of this when we look at this rule. Any number raised to the power of 0 is equals to 1. Think about it. We can do this for any number. Let's just say I gave you 9 over 9. Okay, that would mean it's 1 because it's 9 nines, that's 1 whole. If we looked at it from an exponent's point of view, it would be 9, 1 minus 1, which would leave me up with 9 to the power of 0. And what do I know? The answer is 1, which means 1 and anything to the power of 0 must be equal. And so that's what this rule tells me. My rule tells me any number when I have a power of 0, my answer is 1. And let's repeat that. I'll repeat it again. Let's see what Mateo has to say.
Hello, ma'am.
Hi, Mateo.
Yeah, ma'am. So let's say, for an example, we have 7a over 7a.
Yes.
Do the exponents cancel each other out, or is it still, do you still write a 0? If that makes sense.
7a over 7a. Okay, let's look
Yes,
at
ma'am.
this.
Okay.
It would have been my 7 goes into itself once. And
Once,
7
yes, ma'am.
goes into itself once. And so that my 7s would have cancelled. Are you with me there?
Yes, ma'am.
My a's would have then been a 1 minus 1, which would have been a to the power of
A
0.
or 0.
And the whole thing would have been equal to 1.
1 only, ma'am. So you don't write a.
No, you don't write a. Think about this. If you have a number divided by itself, you're taking 7a and you're dividing it by itself. When you have a number divided by itself, the answer is always going to be 1. Do you agree?
1. Yes, ma'am. Oh, okay.
So that's how you need to think of it like this. Whenever we have a number that's divided by itself, well, our answer is going to be 1. And we can see when we are dividing a number by itself and we use our exponent rules, we end up with a power of 0, which means I know the answer is 1, which means when I have a power of 0, it just means my answer needs to be 1. Mateo, you with us now?
Yes, ma'am.
Okay, great. Thank you for asking that question. If we were to repeat again super quickly, if I have something like 7 over 7, we know that I can simplify 7 over 7 into 1. How do I know that? If you think back to your fractions, when you have the same numerator and the same denominator, I know that gives me 1 whole. And so my answer over here, I know the answer to this question is going to be 1. I know the answer to 7 over 7 is 1. Let's look at this from an exponent's point of view. I know my 7 on the top, my numerator, has an exponent of 1, and I know my denominator has an exponent of 1. If I apply law 2, and law 2 is the law of division, and it says when I have division with the same bases, I can subtract my exponents. And so that's what I went and I did. I kept my base, which was 7, and I subtracted my exponents. 1 minus 1. That's how I ended up there. And 1 minus 1, as we all should know, is 0. So the answer that I got here when I was using exponent rules is 7 to the power of 0. But I also know the answer to this question is 1, which leads me to believe that when I have an exponent of 0, my answer has to be 1. And that's exactly what this rule over here will confirm to you. Any number raised to the power of 0 is equals to 1. And so you can think of it, when you are dividing a number by itself, you're going to get 1. So that is our rule over here. Whenever we have an exponent of 0, my answer is 1. Let's have a look at some examples. So here, what I know is this looks like I'm raising a power to a power. And so because I'm raising a power to a power, I'm going to go x 6 times 0. I want to kind of stop there and I want you guys to give me a thumbs up if you understand why I went 6 times 0. Thumbs up. I see some thumbs up. Mateo, I'm just lowering your hand. If you have another question, you can raise it again. Okay, everybody's with me on why I went ahead and I said 6 times 0. That was my law 3. Then that's going to give me x. And someone tell me, what is 6 times 0? 0. Thank you, Tando. Oh, okay, guys, my glasses are not on. I cannot see the chat. Just give me a second. Okay, everybody's saying 0. Immediately, I did see you had your hand up. I see you put it down. I hope your question was answered. It's 0, right? We know anything times 0 is going to be 0. So my answer over here is x to the power of 0. And somebody tell me, what is x to the power of 0? Thank you, Tando, Shady. You guys are all super smart. Our last law that we just learned, whenever I have a power of 0, my answer is 1. Okay, hope that made sense to everybody. Isn't it 1c? 1x? No, it's not 1x because look at what my example says. When I have a to the power of 0, my answer is 1. My answer isn't 1a, it's just 1. And so when it's 0, it's 1. Yes. So when we have an exponent of 0, my whole power is equals to 1. And remember, what is my whole power? My whole power will include a coefficient. Nope, I'm lying to you. I'm lying to you. My power will include, let's talk about my base and my exponent. This will be equals to 1. So my base and my exponent together will equals to 1. What happens when we have an exponent? Not an exponent. What happens when we have a coefficient? I am so happy to see that you understand now. Your name is Milani. I'm assuming that's not your name. You can rename yourself or you can tell me what your name is so that I can rename you and call you by your actual name. So when I'm using law 4, my base and my exponent together become 1. And we'll see what happens now when we have a coefficient. Okay, again, I'm raising a power to a power. And so what does that mean? I'm going to say 2 to the power of 1 times 0, x to the power of 4 times 0, and y to the power of 4 times 0. Okay? 2 to the power of 1 times 0 is going to be 2 to the power of 0. We have x to the power of 0, y to the power of 0. And this then leaves me with 1 times 1 times 1, which gives me 1. Where did I get 1 times 1 times 1? 2 to the power of 0 is 1. X to the power of 0 is 1. And y to the power of 0 is 1. So 1 times 1 times 1 gives me 1. Are we all with me there?
Yes, ma'am.
Thank you for that. Yes, ma'am. I didn't see who it was, but I appreciate it. Then we have, if we go back here, now we can see when I have my coefficient, I can include my coefficient, and when my exponent looks like that, then I can include that as 1. So guys, with my exponent laws, don't always think about it in isolation from each other. Sometimes we have to use law 2 and law 3. Sometimes we're using all of our laws in one sum. So don't think of it, okay, can I only apply law 1 or law 2? You have to apply them all over the place. And you'll see that it all comes together once you use all of the laws that you know. It's almost like we have a toolbox, okay? I have my toolbox. And we first started with law 1, and law 1 was the only tool we knew. So that was the only tool I could use from my toolbox. But now I also learned about law 2, and I learned about 3, and I learned about 4. Now I have all of these tools in my toolbox. I can take out as many tools as I want for any problem, and I can use them. So it's not only one. Guys, remember we have 4 laws in our toolbox, and we can use all of them for one problem if we need to. Okay, let's look at example number 3. This is oddly easy. I think so too. It's my favorite of the laws because it's just easy. When it's 0, it's 1. I love that. Cool. Then we have over here, I'm going to have 3. 1 times 0. X. 3 times 0. Y. 1 times 0. Boom. 3, 0. X. 0. Y. 0. What? Is anybody noticing anything from these last 3 examples we did? Anybody notice something? I'll tell you what you should have noticed. Look at this. When I have an exponent, okay, I can't highlight just the 0. When I have an exponent of 0 outside a bracket, what happens is, because of my raising a power to a power rule, what happens is my 0 is going to be distributed into everything inside my bracket. And so there's actually no need for all of this working out. I could have just went straight to the answer and said equals to 1. Why? Because I knew my 0 was going to be distributed into my bracket, and then that means everything was going to have a power of 0. So ma'am, in the exam, if the 0 exponent after brackets just gets 1, 100%. Because think about how much extra work we're doing. I'm going and I'm multiplying my 0 into all of my exponents, but I know 0 times anything is always going to give me 0. So I know when my 0 is outside my brackets, I know every exponent inside my bracket is going to change to a 0, which means everything inside my bracket is going to have an exponent of 0, which means everything there is just going to end up being 1 times 1 times 1 times 1. And that's just 1. So that's that. That's when we have brackets. What about E? What I want you guys to see is there is a difference. There is no brackets over here, which means this is -2 times x to the power of 0. And so that leaves me with -2 times 1. Y times 1, x to the power of 0 is 1. My 0 was now not distributed into my 2 because there was no brackets. And so my answer over here is going to be -2. Thumbs up, thumbs down. Is everybody with me on this one? Do you guys understand the difference between when we have a bracket and when we don't have a bracket? Hando is with me. Thank you. Shady, you feel well? Okay. Not bad, everybody. You guys are doing super well today. Okay, I'm not seeing any thumbs down, so I'm going to move on. Where is my brain break? Oh, thank you. My brain is fried. We need a brain break. Does somebody want to help me with this one? A little. Doesn't every number have an invisible exponent? Yes, it does have an invisible exponent, Bree. I'm not sure what you're getting at, but if you are talking about this one over here, there is this invisible exponent of 1. And it's just like I said, because there was no brackets over here, because I didn't have brackets, let me draw the brackets nicer. Because I didn't have brackets, I didn't have to do my distribution. So what happened is my 0 is only attached to my base, right? Because that's what we know about exponents, that my base is the thing that is attached to my exponent. And then my coefficient is actually just multiplied. So only this section of it will be equals to 1, and the rest of it still remains. I hope that makes sense. 3. And so yes, I do have an invisible exponent of 1 over there, but we know I don't have to do my, don't have to do my invisible exponent. I can just write it as -2. Cool. Anybody? I don't see any volunteers to help me answer. That's okay. I will go ahead and try it. I want to separate it. I see there's no brackets. Immediately when I see no brackets, I get a little bit nervous because I don't want to make a mistake. So I'm just going to separate it. 0 y squared z. What happens is I'm looking, okay, I have multiplication, so I know law 1 might apply because law 1 is my law of multiplication. But I know I need to have the same basis. I'm not seeing anything in here that has the same base. Ma'am, don't you just leave it like that because they don't have the same exponents. So I'm not leaving it like this because they don't have the same exponents. Remember, it has to be the same basis. So it's the same basis, and so I can't apply law 1 because I don't have the same basis. So law 1 doesn't work. I'm just going through all my tools in my toolbox to see which one fits, which one can I use. Because remember, in an exam, they're not going to tell you apply law 4. They're just going to give it to you and you're going to sit there and you have to go through your toolbox and say, okay, does the screwdriver fit? No. Does the wrench fit? No. Does the hammer fit? That's what you're going to have to do. And here we know we don't have actual tools. We have laws. So does law 1 work? No. Why? I don't have anything that's the same basis. So I can't use my multiplication rule. Can I use law 2? Law 2 is my division rule. Immediately, no, I can't use law 2 because there's no division over here. Law 3 is raising a power to a power. Do I have anything that's raised to another power? No, I don't have it. And so that leaves me with law 4. Where am I seeing a power of 0? I'm seeing a power of 0 over there, which means this is going to be 3 times 1. And as we said, we don't have same bases anywhere else. So everything else is going to remain the same. And that means my answer is going to be 3 times 1 is 3 y squared z. Everybody happy with that? Thumbs up, thumbs down before our brain break. Mateo understands. Great stuff. Hando, as always, one of the first ones to answer. And I even see some shades. That makes me happy. Ma'am, if it's a number by the power of 0, that block counts as 1. Yes. So I think you're talking about like this block over here. Yes, this block is 1, and that's what you'll see. I carried on. Everything else stayed the same. And this is why I'm saying if it gets confusing, it's always easiest to separate it into its multiplications. I know 3x to the power of 0 y squared z means 3 times x to the power of 0 times y squared times z. And when you separate it into its multiplication, it then becomes easier for me to say, okay, here is law 4, and I can carry that law down. And once I've carried my law 4 down, it's easy for me to then bring back my multiplication and combine it back all into one answer. Cool. I hope that answered your question. Let us move on, guys. At school, we are at multiplication. We are But at my school, we are at multiply and algebraic expression. I think that's what we're moving on to. Now I'm lying. We're moving on to number patterns next. But algebraic expressions is after that, I think. Okay, yes, I see. Sorry, you guys are carrying on with the brain break in the meantime. Yes. A lot of people are saying Romans. Romans, Nando's, and I see one Burger King. Zach. Yes, Zach.
Ma'am, how are
Mhm.
people saying Nando's? No, Nando's is so good.
Thank
Have
you.
you ever tried Nando's? It
I
is
have
so
the same
good.
question, Zach. Thank you.
Actually, if I had to get rid of them, I'd get rid of McDonald's. I'm sorry.
Oh
But I
no.
have to.
See, I was on the same page with you, Zach, but then I ate McDonald's yesterday and today, so I can't agree with you there.
Okay, ma'am. It's fine. But
Thanks,
don't
Zach.
get rid of Nando's. No.
I agree. I'm with you there. We will protest against everybody who's saying Nando's. It's not that good. Again, guys, you'll always hear me, like, as an Indian, spicy things, that is like the thing. That is the thing. Like, I cannot. Like, even if I get pizza, I'm adding chilies on it. You know, with Nando's, I don't have to do that. Nando's is like good as it is. Burger King must leave. I honestly don't know the answer to this. I think I would also go with Romans because I don't like pizza that much. So whoever said Romans, I agree with you. McDonald's is fake food. You see, guys, here's the thing. I'm here for a good time, not a long time. What is the use of living long if I'm gonna be miserable? Like, I'm here for a good time, so I'm gonna eat my McDonald's. Sorry, not sorry. Okay, moving on. Moving on, we have, guys, something to get rid of forever and ever. Don't ask me what I think because I don't know. Soap, toothpaste, roll-on slash deodorant, or lotion. Toothpaste. Who still goes working? Me. I do refueling. Lotion. The thing is, guys, I can't, like, when I scratch myself and then you see those gray lines. Yeah. Imagine going swimming. Imagine it's boiling hot and you're wearing long pants. So, none. Couple, I'm with you. I'm also saying none. I'm saying none. I know it's one must go. Yes, imagine when it's swimming. I'm sorry. Well, okay, one must go. Let me think seriously. What would I do? Mm, I mean, maybe toothpaste, right? Because there's like mouthwash and floss, you know? Maybe toothpaste, but also lotion. Maybe we could use like oil. Maybe you could use oil, like coconut oil. I don't know. Exactly. Being ashy is not nice, guys. I don't like it. Okay, next one, guys. We have novels. I know all of you are gonna say novels, but personally, I don't think I could not do novels, movies, series, comics. Yes, I'm with everybody who's saying comics. I never liked comics, but there's like those fanatics who are like super novels. You see, this is how I know, guys. Like, the only two things, not one person has said a movie or a series. This is how we know we are the generation of technology. Who reads Animal Farm? I hate reading. No, guys, reading is nice. Reading is super nice. You just have to like get into it. You have to picture it like a movie in your head. It's called imagination, guys. It's what we had to use when we had no TVs. Okay, I wasn't around when there was no TVs. I'm not that old, guys. But it's what I had to do when my parents didn't allow me to watch TV. Okay, I had to use my imagination. Yes, Liaho.
Oh, ma'am, sorry to say this, ma'am, but in your days, ma'am, was TV black and white?
No, Liaho, how old do you think I am? That's what I want to ask you.
I don't know, ma'am. I think. Okay, but you're definitely not in your 40s. I think 30s. Somewhere there.
Oh my gosh. I don't want to tell you my age because that is just so much. That is so much, Liaho. Okay.
Yes, ma'am.
I am 22 years old. I'm not even 22 years old, mind you. I'm about to be 22 next month. But
Yo, ma'am,
whatever.
Yo, ma'am, so
Whatever.
basically, ma'am, you just finished school. Basically, ma'am, you just finished school, basically.
But basically, 4 years ago, if you want to count 4 years ago as just finished school, you know. And
Okay,
thank you,
ma'am, cool.
Committee, for telling Refill how to raise your hand. Yes, yeah. Well, I'm not that old. Like I said, my days was not the days where we didn't have TV. My days is just the days where your parents did not allow you to watch TV. Guys, we had a PlayStation, and that PlayStation was only allowed to come out during the holidays. I look older. It's only because you guys see me in my teacher role, you know? But okay, I'll take it. I'll take that I look older. It's fine. Yes, I had a PS2. We had a PS2, Zach, and it was only allowed to come out during school holidays. Not weekends, not after school, holidays only. Yes, Zach.
When I was young, very young, my mom didn't want to spend money on an Xbox, so we used to play on a PS2, and that's why I asked. But it
PS2
was
is
so
the
much
best though.
fun.
Mm-hmm.
And I'm so mad because we gave it away, but it was because the controller was broken.
Us too. Us too. Us too. Zach, we have the same story. Yeah.
And
PS2
then we
was
also
great.
had the Wii.
Oh, and I never had a Wii. We were never that fancy.
That was fun.
Mm, it was fun. I used to play it with my cousins. My cousins had a Wii. You have a
I played it with my
PS5?
brother.
Nice. Yeah, I also played with my brother. That's how I know. Like, I'm very boyish. No, okay, I'm not very boyish, but I just know a lot of boy stuff because I have two brothers. I'm the only girl.
Okay. That's nice.
Ma'am looks like she's studying her last year in university. I am doing my honors. So last year I got my degree. This year I'm doing another degree. Is the lesson done, ma'am? No, the lesson's not done. We are just on our brain break. Moving on to our last one before we get back to work, everybody. Go-karting, bowling, the cinema, or paintball? Personally, I'm gonna have to pick the cinema because that's boring. Like, I can watch movies at my house, you know? What? You guys are saying bowling. That's kind of crazy. Oh my gosh. Oh, you guys. Maybe because I'm bad. Bowling, I also think Zach and I have the same story. Bowling is fun, but I also don't do it much. Bowling is like an occasion type of thing for me. Cinema. Yes, Liaho, you agree with me, and Katlefo. Thank you guys. Thank you guys. The cinema must go. Like, we can watch movies at home. Come on. Paintball is so nice. Cinema, no, guys, cinema is not fun. Also, the other thing is when you watch a movie in the movies, there's no subtitles. I can't hear anything without subtitles. Doesn't make sense, but that's just how it works, okay? I will agree the cinema experience is good, like with the popcorn, and with your friends or your family, and you're watching like a new movie, but come on, I wouldn't give up any of the others for it. Okay, moving on, guys. Let us look at some examples. So now, remember, guys, we have our toolbox. We know all of our laws. Let us use all of our tools. So we have multiplication over here, and I have division. What do I want to do? I want to go ahead and I want to say, I'm going to teach you guys a trick. Okay, this is a trick my teacher taught me. The trick is that when you have something like this, and you have all of the same base, so when it's all the same base, and we only have multiplication and division, what we can do is we write a big base, and then whenever we see multiplication, we're going to add 2 plus 3, and wherever I see division, I'm going to minus. Immediately, yes?
Hello, ma'am.
Hi.
So ma'am, with this example where it says
Mhm.
a squared
Yes.
times a cubed divided by 8 to the power 4, would it be wrong if like you used BODMAS, ma'am? Like first like multiply the 2 and 3,
Mm-hmm.
which is 6, and then divide. Okay, yeah.
So it wouldn't be wrong, but remember, what is BODMAS? BODMAS is BODMAS. And I know it's super easy to say division and then multiplication first, but remember, division and multiplication go together, and addition and subtraction go together. So what does that mean? When I have division and multiplication, I don't have to do division first and then multiplication. I work from left to right. Left to right. You with me there?
Yes, ma'am.
Okay. So because we could use 100%, you should have used BODMAS, but because it's only division and multiplication, it doesn't matter which order you do it in because we're just going to work from left to right anyways.
Yes, ma'am.
You with me?
Yes, ma'am.
Okay, cool. Yeah, so this trick that my teacher taught me to make this easier is when you have all the same base and it's only division and multiplication, what you do is you write a big base. Where you see multiplication, you can add up, and where you see division, you subtract. And I'll do the longer version of this now immediately, just in case we're still a bit lost. But this is going to be A, 2 plus 3 is 5, minus 4 is 1, and that's just going to be A. If that didn't make sense, I'd get lost by
Maybe,
these
ma'am.
partners. Pleasure, immediately. They told us to use BODMAS. Yes, guys, BODMAS applies to anything. We don't pick and choose when we use BODMAS. The default is we are always, always, always using BODMAS. And so what would that look like? I would have gone A2 plus 3 divided by a to the power of 4. So I just dealt with this section first, and that gave me 2 plus 3. Why? Remember, we're using our toolbox. Law 1 says multiplication. When I'm using multiplication and I have the same basis, I add my exponents. So that's going to give me a to the power of 5. And we're still dividing by a to the power of 4. And now what's left in my toolbox that can be used here? This is law 2, which is the law of division. And that is going to give me a 5 minus 1, and that was minus 4, and that was going to give me a to the power of 1, and that was going to be a. Another way we could have done it is I could have gone ahead and I could have changed my sum into a fraction. So I could have said, okay, Refilwe, I'm starting a new method. See if you understand this method. I had a to the power of 2 times a to the power of 3. And then I was dividing by a to the power of 4. I know I can write division as a fraction. So I could have done that. And then what happens is I have a 2 plus 3 on the top and a to the power of 4 at the bottom. How did I get a fraction? I changed my division into a fraction. And then on the top, I'm left with a to the power of 5 over a to the power of 4. And that is going to give me a 5 minus 4. Man, my a's look like 9s. I know, I see that. I don't know how to fix it. That's just how I write a A. Like, is that better? I hope. And that is just going to give me a to the power of 1, which is just a. I hope nobody was confused about what's a and what's a 9. But there you go. This one, let's rewrite that so it looks nicer. That's a A. Okay. Who was lost? Refill with? Can you give me a thumbs up if you're with me? Thumbs down if you're still lost, or you can raise your hand and ask me a question. Refill with is with me. So guys, maths, so many methods, so many tools. There's not only one way to use a hammer. There's not only one way to use a wrench, guys. I don't know, tools. There's many ways to use the tools that we have. Either way, as long as we are using the correct methods, you're going to get the job done. A tool is a tool, you know? So cool, that's that. Let's move on. Let's do this. Let's see. I'm sure we can finish this and maybe another one before our lesson finishes. Let us look at this. 4xy cubed over. Someone tell me, what is my denominator going to be equal to? Anybody know? How do I simplify my denominator? And I have to give Handle a round of applause. Thank you, everybody. My denominator is just 1. So that's going to be just 1. I could have used the long method, and I could have went and I could have said 12, 1 times 0, x 1 times 0, y 1 times 0, and gotten 12 to the power of 0, x to the power of 0, and that's going to be 1 times 1 times 1. But that's a lot of work when we know our rules. So I can just go straight into it and say, that's my denominator. What's my answer? 4xy cubed. Why can't I do anything? Law 1, multiplication. I don't have, or I do have multiplication. 4 times x times y cubed. But do I have the same basis? Nope. So law 1 won't work. What about law 2? Do I have any division? Well, I dealt with my division of 1, and that's just the numerator. So law 2, I've used law 2 already. What about law 3? I used law 3 in my denominator. That's my raising a power to a power rule. And then I knew I could have used law 4, and that's my power of 0. Immediately, yes.
Ma'am, I just want to ask, with the law of exponents, are there any other laws, or is it only 4?
For now, for your grade 8 work, it's only these 4 that you need to know.
Thank you.
With pleasure. Okay, so to everybody who got 1 in the chat, super, super, super well done. I tried to give everybody a round of applause. If I didn't, I'm sorry, but there we go. Ooh, a fun one, maybe. Let's see what our other ones look like. I don't know. I don't know. How do I pick? Okay, let's just go with this. Jump scare. Jump scare, except we're super smart now, so we're like, it's not that scary. I know how to do it. Let's deal with it one step at a time. How many laws are there? For you, there's 4. In grade 9, you learn about 1 more. Okay, so let's deal with only this first part. It's raising a power to a power. What in my toolbox fits? Law 3. The quiz should be out. I actually think I timed it wrong. I timed it for 5:30. But yes, the quiz is out. The quiz is out. We're applying law 3 over here. Let us go x cubed y 6. Why did I do that? I went 3 times 1, 3 times 2. Let's apply law 3 to my denominator as well. X cubed y cubed. Before you guys leave, give me a thumbs up. Are you with me there? Where do we find the quiz? Remember, you'll find the quiz in the Google Classroom. So if you go into the Google Classroom, you'll see there's an assignment that's been posted, and that is where the quiz will be. Okay, so we're with me there. That is cool. Let us now try and simplify this. I see division. Let me use law 2. Okay, law 2 is division. Where did the 6 come from? 2 times 3. I applied law 3, which says multiply exponents. Are you going to post tomorrow on YouTube? Yes, the video will be up on YouTube tomorrow. Let me finish this up super quickly so I don't keep you guys. This is going to be x 3 minus 3 y 6 minus 3. How did I do that? I applied law 2 over here, 3 minus 3. I applied law 2 over here, 6 minus 3. What am I left with? X to the power of 0, y to the power of 3. Let's now deal with the second bit. We have multiplied by, and here, this is going to be, I could go and I could say 3 minus 0, or I could just go ahead and let's go x cubed y squared over x to the power of 0 is 1 and y. Let's simplify that. I can see I can use law 2 over here. Oh, law 2 is what? Law 2 is division. I can use my division law over here. How is that going to look? I'm going to have x cubed y squared minus 1 over 1. Let's simplify. What is that going to give me? It's going to give me x cubed y to the power of 1. I hope everybody is with me up to this point. And now can you see we've simplified it into something that doesn't look so super scary. X to the power of 0, I know is going to be 1 times x cubed y. And I'm going to use law 1 over here. My last step, I see same bases and I see multiplication. So my answer is going to be 1 x y 3 plus 1, leaving me with an answer of x y to the power of 4. Where did you get the 1 when you said 2 minus 1? Over here. Remember I applied law 2 over here. This y has an invisible exponent of 1. So because it was same basis, because it was division, I minused exponents.